Okay, perfect. I think there are at least the people who accepted the invitation. So I think we should start. Hello, this is Thorsten Hülsmann speaking. I was the organizer of this webinar session. Actually, there are people present from two projects. Industrial Data Space Association is active, and therefore I would suggest that we do not make a round the table, but later in the agenda point discussion, question and answers. If there are questions, then it is the time for everyone who asks a question to introduce himself. And not to waste any time, I would now hand over to Lars Nagel and Sebastian Ambos to start with webinar on industrial data space. As agreed upon, we will start with a couple of minutes where Lars gives the overall introduction to industrial data space. This might be already done by myself in the respective project meetings in the past weeks, but nevertheless, Lars has always some more important things to tell as I do. Then afterwards, Sebastian, who is the lead architect of industrial data space, will go into detail of the architecture, the connectors, and maybe also some security topics, because this have been in the past weeks the most important questions of the project partners, and we thought that it is a good way to organize such a webinar to deal with these questions which could not be answered in detail by myself. So I would ask Lars and Sebastian to go ahead. And for the others, I think it would be good to just mute that we don't have any disturbing noises in the line.
Okay, well, thank you for handing over. My name is Lars Nagel. I'm the Managing Director of the Industrial Data Space Association, and I want to say hello to all of you. I'm very glad that you joined the webinar on the industrial data space approach. My role is to give a short overview on the industrial data space and what is our mission and our vision, and what can the industrial data space approach be used for, and what can be the transformative force of the industrial data space. Well, what are we talking about if we're talking about the industrial data space approach? We're taking care of data as an economic asset. We're talking about the data economy, we're talking about platform economy and all these buzzwords you all know. The key focus for this new kind of economy, the data-driven economy, is in linking data and to see data as an economic asset that has a value in itself. Well, if we're talking about data, we're not talking about emails and sharing pictures, but we're talking about data which have a certain value, sometimes a very high value in itself, like a technical drawing, financial data, mobility data, material characteristics, and a whole bunch of sensor data, for example. That's what we're talking about, and if we really want to bring the data-driven economy, the data economy, to life, we have to see that we can connect as much data endpoints as possible to set up new business models and to bring this so-called data-driven economy to life. Well, if we're talking about the data economy and if we're talking about the Internet of Things, there is one thing that seems to be forgotten, and it is the linkage of data between completely different data sources that are hosted in different security domains. The next picture shows something like a tutorial for data economy, how to data economy, how to unleash the value of your data. What is the problem if you want to unleash the value of your data? The first step you have to go is you have to make the data available as a first step. That means you have to bring the data from your company, from your own ecosystem to a data endpoint that is exposed in a certain way to the internet, so that others can use that, can link with that data endpoint, and that you can build up the network as I explained before. So the first thing is make your data available at the first step. And you know, there are questions like how to bring data from the field level or from somewhere else to an endpoint that is exposed in the internet. Sebastian Steinbus will come to that later, how that can be technically be solved. Then, if this data endpoint is exposed to the internet, you have to link with ecosystem partners. So you have to find partners who have the same understanding of sharing data as you, and who want to share or exchange data with you. That means we need a certain ecosystem where all participants have the same understanding and follow the same rules in order to do business or whatever together. Well, if the data is there and if you have partners to play with, the third step will be to control the data flows and to control the access to your data, because, as I mentioned before, the data are of high value, and it is your goal to protect this data, or at least to control the flow of the data. And perhaps you want to know who uses your data for data provenance reasons, or you want to earn money with the data, so you must know who uses the data and how he does it, and perhaps you want to get money from that. So we have to talk about something like usage control and enforcement. And the fourth point is, if these first three steps are done, you can start creating value in a manner you haven't been able to do so in the past. And that's exactly the approach of the industrial data space, to empower companies to create value in a completely new way. And if you have a look at the picture on the slide, you see what I mean with connecting all imaginable data endpoints with each other. What we want to achieve with this standard of industrial data spaces, to empower companies to connect every imaginable data endpoint. For example, on the top right, you see the field view, the factory level, like actors, sensors, and machines. You want to connect them with marketplaces, with IoT clouds, as you see in the bottom right. On the other hand side, if you have a look at data sources and data endpoints in the value chain and the respective IT systems like an ERP or PPS or manufacturing execution system, you have to be able to combine and bring these data to the industrial data space too. And we must not forget the open context data, public data that is available, like traffic data, weather data, or something like that. And if you have a look at that picture, it is very clear that you can set up new business models in combining these data. And on the other hand side, if you are closer in the topic of the Internet of Things, you know that there are today a lot of obstacles in combining data endpoints that are in these blue, green, yellow, or gray circles. And to overcome that obstacle, the industrial data space approach will be a very smart solution. Well, to put that all in a nutshell, what is the real new thing with industrial data space, and what is the real value proposition? Well, what we can provide for companies is the self-determined control of data flows. And on other slides, you see the expression of data sovereignty. That's exactly what we need. We must empower companies to stay in the driver's seat in concerning the control of data flows. And what does the industrial data space approach provide? Well, the first thing is something like endless connectivity. Well, that means, as I expressed before, the standard for data flows between all kinds of data endpoints, and really connect all imaginable data endpoints in the Internet of Things, not regarding the source of the data. The data can come from different proprietary cloud solutions and all other data endpoints you can imagine, and we provide connectivity with industrial data space approach. The second thing, and from my point of view, it is the most important and the most the thing that most people don't have in mind if we're talking about the Internet of Things. Cybersecurity is something that is solved and that works from the concept for one security domain. That can be, in most of the cases, it will be the company. Perhaps it is an ecosystem where there's a focal company who safeguard and who provide the trust for others in the ecosystem, and who provide the cybersecurity. But if you really want to connect data endpoints from completely different security domains, there's a problem, and that has to be solved. You want to share data between different security domains, and the industrial data space is the first approach to solve that without being in one proprietary domain. And the third thing is regarding very deeply the aspect of data economy. Well, data economy has as a sense in itself creating value and earning money, and therefore we need a mechanism for providing that to an ecosystem. So we have to talk about governance for the data economy, we have to talk about usage control and enforcement of that, and exactly that can be provided by industrial data space. So endless connectivity, trust between different security domains, and governance for the data economy, that is something industrial data space provides, and what is really new, and we need a lot of partners to bring that to a global adoption. You see some things you have to consider if we're talking about the industrial data space that has to be done and solved or taken into consideration. Sebastian Steinmus will come to that later on. Just to highlight it in a first step, we have to talk about trust as the basis of the industrial data space, and we have to have a closer look to something like identity management and user certification. Then everything needs to be secure. We have to talk about security and something like usage policies, trustworthy communication, and security by design. Sebastian will show us later on how that works. Then if we want to link data, we have to talk about an ecosystem of data and how to build up that ecosystem of data, how to explain, find, and understand data. Then we have to take into consideration something like vocabularies and brokering and so on. And if we're talking about connectivity, we have to make sure that each data endpoint can be connected with each other. So again, we have to talk about vocabularies, about data formats, and the connection of multi-cloud approaches. Then the last 2 points are concerning the point of data as an asset. If we're talking about data that is shared, we want to create value on that. So we're talking about manipulation of data and apps that can do that. And the 6th point is if there's data and they are of value, then we will have data markets where data is traded as an asset, and then we have to talk about clearing, billing, brokering, and use restrictions and legal aspects. Sebastian will come to that later on. Just some more words on our approach, how to bring that open and global approach to life. We have the Industrial Data Space Association as a not-for-profit and open organization. By now we have something like a little bit more than 80 members within the association from many countries. You see it on the slide, and we are active for nearly 2 years by now. We will release the reference architecture version 2 on the Hannover Fair in 2018. In parallel, we are working on a standard for the connector as a core component of the industrial data space approach with a DIN. That is an open process. Every company, every organization can join that process. We have to go international and include ecosystems from each country. So I'm very happy to have you here in this webinar, and please take the industrial data space approach, make yourself familiar with it and bring it to your ecosystem, and tell that there is something being forgotten in the Internet of Things, and industrial data space will be a solution to that. To make the industrial data space approach work, we have to set up a certain ecosystem with basic functionalities like identity management and security monitoring, and the go live will be in next year, so that there can really be an IDS certificate, and you can say, well, do you exchange data or do you provide data with industrial data space? Is your data endpoint industrial data space certified? Okay, you are trustworthy, I can do business with you. That would be the vision for the future. Our use cases make it happen. All companies within the Industrial Data Space Association start or have already started building up use cases. We have a lot of use cases that are up and running. They are partly documented. There are reference use cases that are described and documented. You can get these information into the Industrial Data Space Association. We have a social collaboration portal where you can get access to all of that. You see some of the big use cases on the slide, and each member, each ecosystem should integrate further partners from all imaginable domains to bring the industrial data space idea to life. Well, for those of you who are not part of the Industrial Data Space Association, I would be very happy if you would join the association. I would be very happy if you would bring the idea of industrial data space to your community, to your country, and set up an ecosystem. Well, thank you for listening, and now I'm I'm handing over to Sebastian Steinbus, the lead architect of the Industrial Data Space Association, who will have a further explanation of the technical and architectural approach of industrial data space. Thank you from my side.
So, thank you, Thorsten and Lars, for the introduction. I will, as already mentioned, bring you closer to the basic ideas of the IDS architecture. To give here a brief introduction, most of the technical architectural work up to now has been done by Fraunhofer, as we started as a Fraunhofer research project, and so most of the concepts I present you root here in the Fraunhofer Association. And yes, I will show you some concepts that we have already published in detail, and I will also give you a brief preview on things that will be published with our next reference architecture document in April 2018. So please see some slides as a current work in progress, but the basic concepts will stay the same until the publication. So the first slide I want to show you is about how and where we see us as the industrial data space, because we only cope with a very, very small part in the architecture of data ecosystems or even enterprise architectures. Typically, one starts with a real-time area with sensors, actuators, devices in the field view, and that are connected nowadays via the Internet of Things. We have broadband infrastructures, 5G infrastructures, for example. To make use of all this data that is processed here, you need some kind of data, basic data services, for example, information fusion, mapping, aggregation, and things like this. And what you want to have are those smart data services, like alerting, monitoring, data quality, deeper analytics, or even integration into business processes to enable yourself for new digitized services and product innovations. And so this is something that is needed in every domain nowadays. We cover only one small part in the connectivity of things, especially between enterprises. And this is only a very small part, but not very easy part, and something that a lot of other initiatives cope with, but not in that detail like we do. So what we promise is a bunch of things. We are an open approach. We are neutral and user-driven. We want to deliver trust because we only have certified participants and components. We are a decentral approach, so we are not the next cloud infrastructure. We have a distributed architecture to provide sovereignty over data and data services. To do so, we need to establish the data governance, the rules of the game, as Lars already mentioned, and so we can set up a network of platforms and services that scale in economies, so you have a network access. And in the core, we want security in the data exchange, because this is the ultimate foundation to establish data economies. So, and then the question is, of course, how do we do this? As I said, we are a decentralized approach, so we always talk about those connectors. There may be a difference between an internal IDS connector and an external IDS connector, but basically only connectors can talk to each other. But if some connectors want to exchange data in a peer-to-peer approach over the internet, each connectors have to find each other. So this is why we need something like a broker, the industrial data space broker concept. It's some kind of yellow pages, a registry, something like this, which only knows about the metadata of each connector. A broker never knows the real data, he only knows about what connector can provide which data. And so because we do not standardize the data itself, it may be necessary to transform data, for example, because if you take a look at logistics, one maybe have EDI data and the other company needs wages data, but this is transformable. And so we provide a concept of apps that can transform data in protocols and in formats and do a lot of more stuff. I will come back to this later on. The other approach we provide is the approach of vocabularies, which is a semantic description of data and of data services. So providing those vocabularies, peers can derive those vocabularies and have a common language to exchange data between each other. So this is a basic concept here. And I hope it's not something completely new to all of you, because you have all heard something about the industrial data space yet. So let's get a little bit more in the details. As I said, only the connectors exchange data, and our connectors give the access to the industrial data space. They are standardized, they have a standard architecture, and they have a standard communication mechanisms. So they do exchange data, and they always exchange metadata between each other. And the core concept here is that it doesn't care which connector it is, the communication is always the same from one perspective. But of course the data changes and the visibility of data changes. So a connector is always connected to a data source at the data provider, and is connected to any kind of data sink at the data consumer, or maybe with an analytics app or something like this. As I said, the broker only knows about the metadata, so every connector has to register itself in the first place at a broker. The broker is not one broker, there may be different brokers, because we always talk about different kind of data, and the broker may be specialized on some domains or on some data sets. And we also talk about the App Store, where trusted apps are available that can be easily plugged into any connector. Why we do need this, I will come back to later on. So let's take a closer look at the reference architecture of a connector. We do differ two parts, basically, the execution part and the configuration part. The execution part contains of three items. It's execution core container. This is for the connectivity, to create messages, to route messages, and to work on those messages. This is some kind of standardized and can be used with different technologies. For example, an ESB could be such a solution, or a camel implementation. This is some kind of standard that is already available, but we specify how it should be used to establish a secure handshake and a secure data exchange. The custom container on the left is the adapter for internal systems. So maybe you want to connect here your IoT devices, or your database, or your ERP system, or a lot of more systems. So this is a custom container that connects your internal systems. And in between, we have the container for the App Store. Here you can easily plug in some apps. As I said, maybe some protocol transformation that you want to consume, a REST-based service, but your partner provides only the SOAP-based web services. And so this is transformable in the protocol way, and other protocols are transformable in a similar way too. You can also do some change in the data formats, what might be simply necessary because you want to have a common language in your own company, and you have a common language outside your company. And the fourth part is the configuration part. The configuration manager is simply for different configurations of your connector. This can be done, for example, rules-oriented, based on business rules, but it can also be process-based, so that you can easily change a configuration depending on your communication partner. Here is an example with an individual setup with apps. For example, here an IDS data core is plugged in with the vocabulary. For example, here GS1 XML. It may be any other vocabulary too. You can provide some kind of data apps, for example, for protocol transformation, data transformation, or pseudonymization of data, for example. Maybe you need an app for aggregation or analytics too, or something like internationalization. The basic concept of communication has two phases in the industrial data space. This is the first, the easier phase of communication between two partners. So here we have a data consumer and a data provider. The connection between both is always encrypted. And so the consumer may state a query to the data provider. This query, before he can state this query, he has to be authenticated, and he has to be authorized. So the connector takes this query and puts it into any kind of connectivity app, the custom container, which queries, here in this example, a facility. Maybe it can also be a database or something else. The result will be tagged with metadata that is necessary for the industrial data space and send the data to the data consumer. And he can maybe do some analytics in an app and put the result via the internal interface to his own systems. So this, as I said, is the easy and not very surprising part. But what we also do provide with industrial data space infrastructure is remote data processing. So here, the algorithm will be transported from the data consumer to the data provider. For example, if you make use of genome data, then you have terabytes of data that you cannot easily transport via the internet. And so maybe it is only necessary to find anything in this large result set. So you send the algorithm to the data provider. He will process this algorithm on the data he provides, and only the result, okay, I just see that I translated run result, not to the English, but only the result will be transferred to the data consumer. And this is necessary, for example, for large data, or in some cases when you don't want to send the data to another party, but you are able and willing to run a remotely executed app in your own infrastructure. The third part, when it's not about providing data or providing an algorithm, is about data usage control. And this is one very big benefit we provide from the IDS. Typically, we talk nowadays about access control, gaining access to something, to someone. But this is only for past and present. For future usages, we need some kind of other obligations. And this is where we talk about usage control. So when the data has left my own connector and is into the connector of someone else, typically I don't have any control on this anymore. So I don't know if he copies the data, for example, or if he changes the data before he gives it to a third person. And so this is what we would like to control. It's something someone calls sometimes a digital eraser. You want to have the control that when I give my data to anyone else, that he, for example, deletes the data after 3 days because they are invalid after those 3 days. And this is where we take care about exactly this usage control topic in the IDS. This is something quite new, which will be detailed far more in the next reference architecture document. We do this with a kind of standard approach. We do have the typical components here, like policy management points, authorization points, information points, and policy decision points. And we can enforce this with a policy enforcement point. Here, the policy enforcement point intercepts the data flows and enforces the decisions from the policy decision point. And he always performs actions in the systems. So this is a kind of a standard approach, but what we do need here are the policies that describe the data usage, and we need technologies that can enforce the data usage control. What we do now is usage controls extends and substitutes and completes organizational rules or legal contracts. So, but as you see in this figure below, you cannot technically enforce everything nowadays, and I don't think that we can enforce everything in the future because there are some issues that cannot be solved in a technical way. So today, most of it is enforced by organizational rules and legal contracts. And we can do some technical enforcement with usage control now and in the future. Yeah, it's kind of similar to when you're driving on the streets with your cars. So you have certain rules there, and there are in some kind enforced, but you cannot enforce everything technically here. To have a small example here, we have here from the automotive industry. Here the OEM receives some data from the risk management system of the tier 1 supplier, And what he wants maybe to provide is an obligation that this information can be seen, for example, in the supplier management system for the logistics stuff, but maybe not for the people who buy the stuff. And so you have an enforcement into the organization. And you can also do something like delete data after it was used. We do have currently 3 technical implementations of usage control that we are talking about. It's the in-use framework that is developed within the Fraunhofer IDS. We have a label-based usage control that is called Lucon, and we have information flow tracking and provenance tracking from the Third Fraunhofer Institute. But what we want to show here is that someone is able to provide policies to describe the usage of the data, and there is a technical way to enforce the usage control in other connectors. So we are not stuck on those 3 technologies. There may be also other technologies available that can implement usage control enforcement. What we want to provide is trust. And trust means that only trusted connectors and trusted parties can exchange data. And so what is here necessary is the identification of participants and technologies in the industrial data space. This is absolutely crucial to enable a data ecosystem. So the prerequisites here is the certification of participants and connectors. So the connectors are certified, so they are tested, that they are able to work with industrial data space and accord to the rules of the game. This is a technical certification process, but we do also an organizational certification process on participants to show that they are able to set up some basic security concepts that are necessary to exchange data. So if you have, as an IDS participants, certification process done and have your certificate, and you have any kind of connectors that is certified, you will get a digital certificate, an X509 certificate, which you put on your connector. And this is the entry point to be part of the industrial data space, because the first thing when 2 connectors talk to each other is that they present their digital certificates. And they establish a secure connection between both parties based on those certificates. So if you don't have this certificate, you cannot establish a connection to another connector. And to be quite clear here, every other component in the industrial data space, like an app store, like a broker, or like an identity provider, is in the first place an IDS connector. So this mechanism is always necessary, and this is why we talk here about the handshake of connectors. And this is the minimal set connectors have to do. They have to establish a secure connection between 2 parties, and then in the second step, the consumer requests the self-assessment from the other participant. So this is described in our information model that describes the participant and the connector itself and the data endpoints. So then I can take this self-assessment and validate this against an identity provider if I want to. I do not have to do this. I can trust the other connector, and if I do not trust this connector enough, I can validate this against an identity provider to see if this information is valid or is still valid, because maybe the security level of a connector has changed in between. So if this is validated, you can check if the partner is trustworthy enough for the data he requests. And if he is, then I can check further if the provided data is consumable for me. For example, if you have one connector from a medical system and the other connector is from a production system, so the data will be incompatible by nature. And so the connectors will see, okay, we can talk to each other, but we do not understand each other. And so they will not exchange any data. But if the data is consumable, then they can exchange the data finally. This is the basic IDS handshake process, which is our main idea how to establish trust between the different parties. Because every connector can decide sovereignly if he wants to exchange data, but on the other hand, we have a standardized connectivity that every connector can at least find out if he can talk to another party. So here we are stuck on certain protocols. For this handshake, we make use of HTTPS or MQTT. Every connector has to support both. When it comes to the exchange of data, we are not stuck anymore on any kind of protocol. You can make use of any protocol that you like, may it be a request response or a queuing protocol. You're totally free here. So what I've been asked a lot lately was, so here you have your architecture, but where is your API? And what we always say is, so we don't have an API, but the IDS provides an API for your own API. And this is our information model. So to get a brief idea of the information model, there is an abstract and descriptive conceptual representation. It's a document and something like an UML notation. This is written down in the IDS reference architecture. So in the next step, we have a declarative representation in RDF, as an RDF file. This is our ontology, which describes everything inside the industrial data space. And what we also provide is a programmatic representation, a reference implementation, the IDS information model library. This is at the moment a Java implementation of this IDS IDS ontology. So we focus in a high-level view on the 4 domains, which are not very surprisingly, I think. It's about participants. So who are the participants in our data network and how the participants can be described? For example, what is their name, which kind of legal entity are there, and which kind of security mechanisms they provide from an organization level. We describe, of course, data and data products, because this is our primary goal, to describe data and data products and to share those data products. We describe also the infrastructure, which is mainly the connectors and the endpoints that are available via this connector. And we describe the applications that are available in any kind of way. So to give here is a deeper introduction. I cannot introduce the complete information model today, because it is quite complex and quite worked out in detail. But it is already publicly available via GitHub. You can find the core of our information model here. But what we focus here is the data as a product. So the legal and economic overlay and the data as a commodity. To get this data, you need some information about the retrieval of this data, and this is a description of the data endpoint. And to make this clear, one connector can provide different data endpoints, can provide different data, and can provide different interfaces. So the data endpoint is a realization of the interaction interface via a concrete protocol binding. For example, this may be a standard REST service, or a SOAP-based web service, or maybe even an FTP server, for example, can be a data endpoint. And then the interaction is described within the data interface, the abstract interaction interface for querying, listing, retrieval, and things like this. For example, this may be a WSDL interface or an OWLS service profile, things like this. And here is exactly the point where you plug in your own APIs, as in WSDL or anything else. Yeah, this is provided here. And what we want to provide here is the ability to set up the client interfaces dynamically. So you get this OWL or RDF description of the data endpoint, of the data interfaces, and then you can set up dynamically your client interface for consuming this data, for doing the interaction with the other participant. And of course, we describe the content, the structure, the context, the classification and provenance of the data assets, which is basically a data set but can also contain some kind of metadata. For example, the policies for usage control. To get a little bit more into this data endpoint, this is exactly as I said before. Here is your own API. You have some kind of data endpoint that you want to expose via protocol binding, bind operations on this protocol with parameters and other bindings that are maybe necessary. And finally, one more general idea from the IDS. What we've seen from our use cases is that we do need different connectors. And we want and we need different connectors, but we need to define some classes of connectors on the other side. So what we've done so far is we've taken a closer look at our use cases and take a closer look to generic use cases, so scenarios that can be set up within the IDS and that show the benefits of the IDS. And then we changed this, we derived from here the dimensions for security or usage profiles. And what we've identified here are the 4 dimensions: development, the supported roles, the communication abilities, and something miscellaneous or higher security classes. And what we found are 4 security profiles, and this is absolutely important. Because we find those 4 profiles that are needed for the users of the industrial data space. We have the base free profile, a base profile, a trust, and a trust plus profile. So the names are not chosen very well, so we will change that until April 2018. But one understands what we mean. There is this base free connector, which I would like to state as something like a do-it-yourself connector. You can use it for internal work only. You can use it, for example, in a research project and develop it on your own and set up your own infrastructure. But what a base free cannot do is connect to the public industrial data space because it is not certified. That is not certified, and so it cannot connect because it cannot have an IDS digital certificate, and so it cannot connect. But if you do a certification successfully on your base free connector, then you will get a certificate and it will be able to connect to the public IDS. So this is only an organizational change to make the IDS idea work very broadly. And the next very important thing is that the base, the trust, and the trust plus connector are always able to communicate with each other. I already mentioned this, but this is absolutely crucial, that every connector can talk to each other and then decide if he wants to talk to the other connector later on, and if he wants to provide data or even receive data from any other connector. Yeah, this is the basic idea here, and to go not too far in the details, I'd like only to bring you some basic points here. So the development of the reference implementation for the base free connector will be done as an open source project. Base and trust will be developed inside the IDS community. So if you want to be part of the reference implementation from the IDS base or trust connector, then you have to be a member of the Industrial Data Space Association. The Trust Plus connector, or maybe something like the Managed Trust Plus connector, is bound to more strong SLAs. For example, that security patches have to be delivered in time, and that you have, for example, some certain development roadmap of security functionalities. So this is a smaller community than only the IDSA membership community to deliver some special trusted features here in the development. What you can do with every class, you are not stuck on the reference implementation. Of course, you can build your own industrial data space connector and sell it as a product. And you don't have to provide your sources, your source code to the community. You can easily set up a product, but this product will be in one of those classes. It will be a kind of base connector, a trust, or a trust plus connector, depending on the certification process and on the result of certification. So coming down to the roles, as I said, the base 3 connector can only connect to their own infrastructure. The other 3 connector types connect all other IDS roles. That would mean brokerage, connecting to other connectors, identity provider, supporting an app store, supporting vocabularies, and supporting clearing and billing. But for the base connector, the support of billing and clearing may be optional. Of course, you can implement a billing and clearing connection, but he doesn't have to, because sometimes the base connector will not be trustworthy enough to do billing on the data. The trust and the managed trust plus connector have to support all IDS roles. In the communication abilities, as I said, the base 3 connector can only connect with self-signed certificates to other base 3 connectors. The base connector and the other the trust and the managed trust connector are fully interoperable, as I already said. But the base connector has only some kind of reduced trust. That means, for example, that you do not have a decentralized or a remote logging facility, that every data exchange will be logged also remotely. And so it is reduced trust here. And the trust connector is fully operable, but has the free decision of communication if I want to communicate with another connector. This also is for the Trusted Plus connector, but the Trusted Plus connector has to set up a hardware anchor, for example, a TPM module, to deliver higher security, that the hardware and parts of the software stack are not changed by any kind of user. And so in the higher security classes, we define some things in more detail. The base connector, of course, delivers standard security level and can implement everything that the Trust and the Trust Plus connector does, but he doesn't have to. So this is mainly the use of TPM modules. This is also the ability of remote logging abilities. And this is also the monitoring interface. Every connector can be monitored by any kind of security operation center to find out if this connector does anything evil, for example. If he consumes a lot of data, this may be a pattern to say, okay, there might be something wrong. Or if there is any kind of security update necessary, for example, we all remember the Heartbleed security issue. If the security patch is not applied yet, then the security level of the connector can be lowered. So this monitoring frequency is it's a managed trust connector and nearly real time done. For the trust and the base connectors, the monitoring activity is not so high. But this is a very, very important feature, because we are working based on X509 certificates. And what you can only do here is provide a certificate and revoke a certificate. With this monitoring mechanism and providing the result of this monitoring via the identity provider, I am able to check if my communication partner has a certain security level. For example, if he is trusted and he has an implementation of usage control enforcement, and he implements things like remote attestation. But I can also then check back at the identity provider if there is any common behavior known from this connector that may mean that he is not trustworthy enough. So I do not have only those static information about trustworthiness, I also have dynamic information about trustworthiness. And then, based on this information, I can decide if I, for example, know this connector and know, okay, everything is fine, or I don't know the connector and I have maybe there are some issues there. And so I will not give him my data now, or will not receive data from him now, but maybe later on when the security level has changed higher again. So this was my brief introduction into the industrial data space architecture. And I would like to start with the question and answering part of this webinar. So, and as Thorsten already mentioned, I would appreciate if you say briefly your name before you ask your question. Thank you for listening.